This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 89, a discussion with AMP Robotics on how they use simulation to improve recycling, along with news and events from the world of Ansys. I want to welcome you to our little podcast here. My name's Eric Miller. I'm one of the owners at PADT, and we're headed into Memorial Day weekend right now. I think that everyone I know who is fully vaccinated is headed somewhere, myself included. I'm returning to Sedona, Arizona for the weekend to spend some time in the shade next to some water before summer hits Phoenix too bad. Because of that, I'm recording this a few days early on Thursday, May 27th. We were relieved to see the pandemic numbers in India start to go down recently and hope that this trend continues. There's many Ansys employees and users in India, or employees and users with family there. We have seen firsthand how the recent spike has impacted people, and we hope that anyone listening has made it okay through this horrible time. And thankfully, vaccination is continuing around the world, and we just noted in the news here that over half of the U.S. adults are now fully vaccinated. You know, as an engineer, I can't help but appreciate the supply chain and logistics required to make that happen when you really think about what they did to get that many shots in the arms and now to spread it out around the world. So it's pretty amazing stuff. So today, for the last couple of episodes, actually, we've been able to set up interviews with some of our customers to speak with them about how they're using Ansys and doing simulation. And AMP Robotics is one we talked to earlier this month. It's a really cool application, and now every time I think of them, every time I take out my recycling to the big blue bin that I toss everything in without having to sort myself. And I'll let them explain why Ansys and their product plays a role in that. I want to welcome everybody today. We have a fantastic discussion with one of our customers who's an Ansys user, two engineers from AMP Robotics, John Byars and Jake Fitzgerald. Hi, guys.
Hey, how's it going?
Hi. Really good. Thank you for joining us. You guys are up in Colorado, correct?
That's correct.
Yeah, I'm down here in Phoenix. So just before we started recording, I was pointing out that it's 100 degrees here today. So I need to spend more time near you guys. I want to thank you for joining our podcast. We'd love to hear how people are using Ansys at their business. So why don't we start, with you guys telling us a little bit about your background, how you started using simulation, and then can one of you share with us what your company does?
Sure, yeah. I'll go ahead and start. So this is John Byers. I come from semiconductor industry initially. So we were on Pro Engineer using Mechanica quite a bit. And then I transitioned into short stint in oil and gas. And then I went into prosthetic design using SolidWorks very heavily. Got very heavy into, we were using SolidWorks simulation. My first exposure to Ansys was actually at that company. We were evaluating Ansys for a simulation tool. We ended up not going that way and stuck with SolidWorks simulation. And then I've kind of migrated my way over to Colorado and started working at AMP.
Great.
And this is Jake Fitzgerald. I have had about 10 to 12 years previously working in energy R&D on energy storage, carbon capture, compressor and expander design. I've used previously SolidWorks simulation, both FEA and CFD tools, and switched over to Ansys about 5 years ago, mostly on the CFD side, using Fluent and CFX for gas turbine design and doing some static simulations and a little bit of multi-physics for the gas turbine design. And yeah, been using Ansys. I love the product.
Well, good. I think I'd really like to hear about the company and what you guys are doing, because I think it's pretty exciting stuff and pretty cool stuff, and something that hopefully we'll all think about next time we put something in that blue bin. Why don't you share with us what you guys are up to?
Sure. I can start. So AMP Robotics, we are developing products for the recycling industry, our flagship product is called Cortex. It is a recycling sorting robot. So we are using machine learning and AI to identify objects coming down a conveyor belt. And we identify the object, tell the robot what to pick up, and the robot just goes over, grabs it, and deposits in a bin. And the main point is to dramatically reduce the cost, excuse me, of recycling. Right now, recycling is usually a break-even business, where our technology can leverage the robotics and leverage the machine learning to drastically reduce that cost and make it more of a profitable business for the plant operators. The robot itself is usually designed to be installed in existing facilities, and we use an off-the-shelf robot and design the entire system around it. So team of software engineers, team of mechanical engineers, and operations and service technicians all come together to make this product a reality. And we have over 125 robots in the field, all across the U.S., a couple in Japan, one in Spain, and we're branching more out into the European market. And it's growing quickly, and lots of happy customers so far.
That's here in Phoenix we have unsorted recycling, right? So we just have one recycle bin, and every time I dump that mixture in there, I'm thinking, who's going to sort this? And so maybe it's an AMP robot, right?
Yeah. So one interesting thing is robots are typically installed where there have been human sorters previously in the past. With COVID, there's been lots of workplace changes of the 6-foot spacing, and our customers are seeing more and more the value of having a robot in replacing a human sorter. And these jobs are dirty, it's not fun, there's high turnover rates. So the customer is seeing the value where they can have a reliable employee that is a robot and picking 24/7 if they choose to operate that way.
Cool. Very good. It's exciting and important application for for this kind of technology, right? Everybody could use this. I'm excited about that. And I want to talk more about the technology and recycling in general, but that's not why we're here. We're here to talk a little bit more about simulation. So why don't you either of you share with us, how are you leveraging Ansys tools to get these robots to perform?
I can start out with that. Generally, most of the time we're doing, kind of like static structural analysis on like kind of sub-assemblies, components, looking at fatigue. Our robot's a high fatigue kind of system where we're running millions and millions of cycles over the lifetime of the system, and we want to make sure that our components are reliable and we're not going to have constant failures or like kind of unpredictable failure modes. So sometimes those things pop up, and we kind of use Ansys as a kind of a root cause analysis tool initially when we're doing kind of like sustaining efforts, and then on the like new product development design side, we're doing our kind of due diligence to make sure that our designs are going to handle the expected loading conditions and the numbers of cycles, and kind of getting a better understanding of stress flow through parts and components and how they interact. So yeah, a lot of static structural analysis on at least the stuff that I'm working on in particular.
Cool.
And in addition, we've started branching out using CFD more on some pneumatic components that we've started developing in-house. Mostly static, some dynamic CFD, internal flow with just air.
Okay.
And we have leveraged Fluent for that, and we have started to design nozzles basically, and using Fluent to get the nozzle profile and the angles and the throat diameter. And we've taken the data that we've collected out of Fluent, and we're trying to post-process that and then validate it in a lab with real-world operating conditions as well.
Very cool. That's very cool. Are you using that to like blow things around on the conveyor belt, or what's the application?
We're developing a proprietary sorting technology. I can't talk about it too much, but
okay.
We have also looked at using CFD tools on the robot for Venturi designs and checking pressure drops across certain components on the robot.
Okay. Yeah. We don't want to give away too much. That's really cool. So you guys have been using it for a little while. What do you like most about the tool set that you've applied from Ansys so far?
On my side, I'm doing, looking at smaller subassemblies up to, a little more complicated subassemblies. We have things like interference fits and spring-loaded kind of clamping systems. One of the biggest advantages I see of Ansys over something like simulation, SolidWorks simulation, is the ability to do like solving steps. I think that like makes it so much more powerful and stable. One of the things I've struggled with in the past is getting those complicated models with like press fits that get loaded to actually solve without doing multiple solve steps. So I find that to be probably one of the most useful things that I've found in the software.
Cool. Definitely a big advantage. Yeah. How about you, Jake?
So one thing I really enjoy about the Ansys software suite right now is discovery. Doing quick iterations and quick design, early designs and running either a quick static FEA or a internal CFD has been pretty powerful in my workflow. And being able to easily see what is happening and make quick changes using Space Claim and then the discovery tool, I think, has been really powerful. And then if it requires a more detailed analysis, quickly jumping into Fluent or structural is fairly seamless as well.
That's cool. That's good. I'm glad. I'm always happy to see people using Discovery because I think it's a extremely useful tool, especially in that upfront, quick and just get some answers and move on. So I'm a huge fan. That's great. Yeah, as I mentioned before we started, sometimes Ansys developers do listen into this podcast, and so here's your chance. Do either of you have anything on your wish list that you would like them to improve or add or enhance in the tool set?
I can't think of like super specifics. I think, for me, it's been a bit of a learning curve, kind of trying to figure out where stuff is located. So. Maybe like a refresh on the UI on the structural system would be something a little bit easier on my eyes. But it's not bad, once you kind of get used to it. But I think it would be maybe a little less learning curve if the things were a little bit more updated.
Yeah. It was new when it was new.
Yeah, exactly.
Yeah. How about you, Jake? Anything?
On my side, increasing the capabilities of discovery, I think, would be really interesting. We have a mixed group of capabilities with analysis on our team. And I think discovery in particular is easy to use and can provide a lot of insight. So, providing either larger mesh sizes, faster solve capability on discovery would be valuable. Make it like a, oops, sorry about that.
No worries.
Make it a first step in the process of getting a simulation done would be really valuable.
Yeah, and I think you guys will get both of those eventually. I know there's quite a bit of effort on adding capability into Discovery, and it's gonna. we're gonna look back on what we do today and go, wow, that's all we had. So I'm excited about that, especially the multi-physics. Yeah.
Yep.
Well, cool. It's been really fun to learn about what you guys are doing and how you're applying Ansys, and I think it's a great example of the different areas that it can be applied to and really make a difference, right? I think this recycling issue is a significant one. Here in Arizona, we were shipping our recycling to China, and they finally said, yeah, no more. And I don't know what we're doing with it now. I think it's just building up. So I hope to see one of your robots in a news story soon about our new sorting facility. So we'll look forward to that. Well, I appreciate. Do you guys have any questions for me or any finishing comments before we close up?
Nothing for me.
Good.
No, I one thing to say is the numbers on the material that goes to the landfill is pretty astounding in terms of what the dollar value is. It's somewhere in the John, correct me if I'm wrong, but it's in the tens or hundreds of billions of dollars per year of what actually goes to the landfill. And so there's massive opportunities to reduce waste and actually extract value out of our waste stream. So AMP, we're trying to envision a world without waste, and the robots are one step in this process. And eventually we'll all get there, and recycling will be one of the most both cost-efficient ways of dealing with waste, hopefully soon, and we will solve this problem.
Well, we love it. I think it's a really great mission and a great application for the technology. And the other thing I'm trying to avoid is deep diving into your AI technology, which I'm also fascinated by. But that's not an Ansys thing. If people want to learn more about your products and what you guys are doing, what's the best place? What's your website and other places for them to get hold of you guys?
Sure. It's just amprobotics.com.
Okay.
You can find us on LinkedIn. We post a lot on LinkedIn. We also are hiring. There's 35 plus positions open right now, all across engineering and operations. So if there's any mechanical engineers that like to work on interesting problems, please reach out.
Oh, that's good to know. So that's you guys are definitely growing, and that's fantastic. So do check that out. I recommend going to their website. They've got a really cool video if you scroll down a little bit that shows one of their machines in operation, which really helps understand what they're doing and the challenges they're facing. So check it out, and if you're looking for a position, definitely check out their career page. That's fantastic. I wish you guys all the success, and we'll follow you guys closely as you grow and continue to change this important area of our I don't know what you call it, our eco cycle. So product cycle, I guess, right? We never think about at the end of life, right? So I really appreciate it, guys. It's been fun, and I learned a lot, and I hope to see you in person sometime this summer when I'm up in Denver.
Definitely.
Thank you.
Right. Thanks, guys.
Thanks, Eric.
Bye.
Thanks.
That's great stuff. It's always interesting to see how and where people use simulation. The cost of separating recycled goods is significant. Here in Phoenix, I kind of mentioned, and I'll bring it up again, we used to outsource that, and we actually made money. The city of Phoenix actually made money when it was cost effective to do it, and now it's costing money. So hopefully automation and AI will bring that cost down and make recycling easier and more impactful. So great to hear that, and hope to hopefully inspired some of you on how to use Ansys in different ways. So for today's commercial, I want to talk about Ansys SpaceClaim. If you don't use SpaceClaim, you should. It's not just another solid modeler. It's not a CAD package. It's a geometry tool for simulation engineers. And every release, it keeps getting better. They keep adding incredible capabilities to it. I can't tell you how many times I've heard one of our engineers say, I just did it in SpaceClaim, when someone asked them how they dealt with some sort of tricky, nasty geometry issue. If you're trying to get a traditional CAD package or some fancy cloud-based program that got acquired by a traditional CAD package to pre-process and deal with your geometry for simulation, you're doing things the hard way. The SpaceClaim is a geometry workshop designed for simulation. Reach out to your Ansys provider for a demo and more information. It doesn't cost much to add it to your existing Ansys licenses, and I think you'll agree very quickly that it'll pay for itself before you know it. SpaceClaim, it's how Ansys Power users do geometry. I just made that slogan up right now on the fly, so we'll see if it sticks. Speaking of things sticking, let's talk about the Ansys stock. It's down. It's down year to date. It's been up and down through March, April, and May. It continues that roller coaster along with the market itself as well as the industry segment. As of this afternoon, May 27th, it closed at 336.79, which is down only 7.4% for the year so far, so not too bad. We'll keep watching it and see if it turns around soon. Maybe people will stop investing in Bitcoin and invest in things of value like Ansys. We'll see. In Ansys news, the big news is that they announced an acquisition. I think in the last podcast, I said there's got to be one coming soon now that they finished out the first quarter meeting. And lo and behold, they announced it. And was a complete surprise to me. I had no idea that they were even looking at this company, but they ended up buying them. It's called Phoenix Integration. A little bit of an aside, most people don't know that PADT actually stands for Phoenix Analysis and Design Technologies. And back in the day, we used to get calls for Phoenix Integration, as well as there was a motherboard company that actually made the stuff that goes on the motherboard, that drives an operating system that goes on the motherboard, called Phoenix Engineering, I think. And we used to get calls for both of them a while back. But I digress. Phoenix Integration adds tools to the Ansys suite that combine different simulation products as well as some of their own solvers together to do what they call model-based engineering or simulation, or model-based system engineering. So model-based engineering and model-based system engineering are the terms they use in their space. So it's basically a way to cook together a bunch of different packages and some reduced order models, I think, as well, and do kind of automate and simplify the whole process of doing complicated model-based engineering. So it's different terminology, so we'll have to get our head around that. But in the press release, they point out the fact that it's the company's based in Blacksburg, Virginia, and they're basically a longtime partner with Analytical Graphics Inc., AGI, who we recently had on the podcast, and are also a recent acquisition by Ansys. So my suspicion is it's related to filling out the needs of these tools that kind of look at system level and model-based engineering to come up with better products, kind of the whole digital twin type of a thing. They also point out that it complements the acquisition of Dynardo, which is in the area of optimization and integration and process automation, and it expands the Ansys capabilities for customers doing model-based engineering and model-based systems engineering. So once things settle down, we'll try and get someone to come and answer our questions, coming from the perspective of longtime Ansys Fluent or Ansys Mechanical or Ansys HFSS users, kind of this new world of model-based engineering, and what does that mean? How does it fit with analytical graphics? How does it fit with our core products in the Ansys suite? And answer all those questions as time goes by. And if you've been a user for a while, you know that Ansys is really good at taking companies in and absorbing their technology and people, and it takes a little bit of time, and they do it the right way. So we'll wait till they're settled and reach out and try and understand a little bit more. But we're excited. I think it's a powerful addition to being able to simulate more and get better information for driving design and product behavior in the field. And other Ansys news of note, they made an announcement about a partnership with Cornell to jointly develop curricula for simulation, especially for online-based learning. There's a lot of detail in there. If you're a student or you're interested in education around simulation, do check that out. It sounds like Cornell is going to do the heavy lifting on the course part, and Ansys is going to do the heavy lifting on the content creation and making it applicable to real-world engineering. That should be a great partnership, and and it may change the way people learn and relearn Ansys. So look for that in the future to bear fruit. We don't have any news here at Ansys or at PADT to share with you. Publication-wise, on the Ansys blog, there were 2 articles that I really liked. The first is actually about Ansys Rocky, who we recently had on the podcast. And it really goes into more detail and with some good images and some great animations on what you can do with this great tool. The post is called Simulate Particle Behavior with Ansys Rocky. My favorite is the one that shows raining gummy bears. And the point of that isn't just to have cool gummy bears fall, but the particles themselves don't have to be spheres, right? Gummy bears are shaped like bears, not spheres. And how they interact with each other and stack up and fall over is a pretty cool example of that. And it's squishy material as well. So it makes for a kind of a cool simulation to push the technology. So do check that one out. The other one is called NG. I'm probably saying this wrong. I don't know if it's ENGIE or NG Lab Cryogen and Ansys Accelerate Zero Carbon Energy. It's really a look at using Twin Builder and some other Ansys tools to really drive down carbon emissions in various applications. So this is a customer, NG Lab, at a company called Cryogen, is looking at how to make things more efficient and get to zero carbon energy, and how to solve that problem, and how to. It's a great example. The reason why I liked it is it's a great example of using Twin Builder to do these kind of high level what if type studies. So cool stuff. And on our blog, at the PADT blog, our engineers have been busy. It's been a great, we've been publishing quite a few articles recently. Based on a tech support call, actually, Alex Grisham published an article called Using the ACT Console for Automation in Ansys Mechanical. And so a customer was trying to automate a process, write his own little Python script to do that. And after we helped them, a couple guys here helped them, Alex wrote it up in a nice PowerPoint. So if you're using ACT to customize, or you've been thinking about learning ACT and using it, you need to check this article out. It's a good look at using the console tool to make customization easier in the Workbench products, as well as, I think, SpaceClaim. The second one was called Ansys software for I got to get this right because the terminology is important in this space. Ansys software for electric machine design. And it's written by one of our newer engineers, Kang Lee, who is our expert in low-frequency electromagnetics and motor design. And it explains the different tools that you can use to basically design these electromagnetic devices, right? What they call electric machines. It's a thoughtful overview that will help you figure out which of these tools. There's several tools you can use to design your electric motor or whatever kind of a product generator, whatever. And it kind of helps you decide what's the right tool and when you should use which one for what. So check that out. Also, new on our blog, actually 3 Fridays in a row, is Miles Atkins, who is our expert in Flownex, has started a series called Friday Flownex Tech Tips. And he's done 3 of them so far. And if you use Flownex, it's a must. He's basically going into, being more efficient with the tool. But if you want to understand why he loves Flownex so much, why we get so excited about Flownex, check it out. It's a good look into why it's such a powerful tool as well. So those are called the Friday Flownex Tech Tips. So the last thing is we published our 4th chapter in a PADT engineer in King Atabal's court. It is a silly serialized novel about an engineer named Ash who is transported back in time to ancient Phoenicia instead of Phoenix. And she encounters all sorts of interesting people and challenges, and shocker, seeing it's being written by engineers, she uses engineering to solve these problems. So it's not well written, but it's fun. It's our 4th chapter. Do check them out on our blog. So, upcoming events, webinar-wise, we have one next week. Jim Peters is going to go over LS Dyna and motion updates in Ansys 2021 R1, and that's going to be on Wednesday, June 2nd. And as always with our webinars, you can go to brighttalk.com and find it there, or go to our website /events and find it there. We also have a couple of online things coming up. The first, it's a series here on aerospace. So as we've done in the past, where we've taken an industry and looked at the 3D printing side and the simulation side of that industry, we're doing the same for aerospace. So we're starting with, let's see if I get the time right on this. The first one's going to be the first one is additive enhancements in aerospace. That's a lot of A's. Additive enhancements. Oh, I got that wrong. Additive advancements in aerospace. And these are all on June 10th, which is a Thursday. And that starts at 10 o'clock Phoenix time. And it's going to take a look at 3D printing. We got some experts in the area from customers and Stratasys. And then we're going to talk about the same sort of thing for simulation. So what's new and different for simulation in aerospace? And that's going to start at 1 o'clock Phoenix time on the 10th. And then we're going to wrap it up with a panel discussion, which yours truly will be the moderator of, where we'll have our presenters from the webinars before come and talk about both 3D printing and simulation and the confluence of the two in the aerospace sector, and that's at 2:30. So again, that's the 10th of June at 10, 1, and 2:30 Phoenix time. I go to our events page to figure out when that is. I'm also going to be doing a presentation on June 15th called at the Virtual Engineering Design and Manufacturing Show. And the presentation is going to be on efficient material selection and management in additive manufacturing. And it's of interest to those of you in the Ansys world because what I basically, I'll give you a little bit of synopsis on why you might want to attend. The basic problem is with additive manufacturing, you got to pick your materials. You've got limited choices, and there's a lot of trade-offs. And generally in that space, people have done it by trial and error. Let's try this material. Let's try that material. See what it does. Basically the talk is going to go over how we use Granta, the Ansys material tool, to make an educated selection of the right material, and then how we also use simulation to simulate the process and the end-use part in the field. Instead of building and busting, we're using simulation to do virtual testing to pick the right material. So check that out. Hopefully you'll enjoy it. It's a great talk, and we'll post a link to it afterwards as well. And we'll finish up the month of June with the Arizona Technology Council is having our virtual MedTech conference on the 24th, and that's all morning from 8 to 12 p.m. Phoenix time. So if you're in the medical device or, pretty much if you're listening to this podcast, you'd be in the med device space in Arizona and want to hear about what's going on in the state in this space, check it out. And that's pretty much it for events and for our podcast. I want to thank you for joining us and for this Thursday edition of the podcast. Don't forget to subscribe to the podcast itself wherever you get your podcasts, as well as sign up for our newsletter at www.padtinc.com/opt-in. Please spread the word. Tell a friend or a fellow user about the podcast, and do not hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 89. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.